Motion in a plane with constant acceleration. Suppose that an object is moving in xy plane and its acceleration a vector is constant. So the average acceleration over an interval of time will equal to this constant value. Let the velocity of object be v naught at time t equals to 0 and v vector at time t equals to t. Then by definition of average acceleration, a vector equals to v vector minus v naught divided by t minus 0 equals to v vector minus v naught vector by t, or a vector into t equals to v vector minus v naught vector. And v vector equals to v naught vector plus a vector into t, equation 1. In component form, this can be written as vx I cap plus vy j cap equals to v naught x I cap plus v naught y j cap plus ax into I cap plus ay j cap into t, or vx I cap plus vy j cap equals to v naught x I cap plus v naught y j cap plus ax into t I cap plus ay t into j cap, or equals to v naught x plus ax into t I cap plus v naught y plus ay t into j cap. Equating the coefficient of I and j in both sides, we get v x equals to v naught x plus ax into t and vy equals to v naught y plus ay into t. Let r naught vector and r vector be the position vector of the particle at time t equal to 0 and t as shown in the figure, and let the velocities of this instant will v naught vector and v vector. Then over this time interval t, the average velocity is v naught plus v vector by 2. The displacement is the average velocity multiplied by the time interval. Thus, r vector minus r naught vector equals to v naught vector plus v vector by 2 into t, or v naught plus v naught, because v vector putting the value of v vector, v naught plus a vector into t divided by 2 into t equals to 2 v naught vector into t by 2 plus a vector t square by 2 equals to v naught vector into t plus half a vector into t square, or r vector equals to r naught vector plus v naught vector into t plus half a vector into t square. Now this can be written in the component form: x equal to x naught plus v naught x into t plus half ax into t square, and y equals to y naught plus v naught y into t plus half y into t square. X is the final position and x0 is the, or x naught is the initial position in x direction. Similarly, y is the final position in y direction, and that is at time t, and y0 or y naught is the initial position, that is at time t equals to 0, and that is x and y represent the final position in x direction and y direction respectively. And if we take x minus x naught, then it will represent the displacement in x direction, and if we take y minus y naught, then it will represent the displacement in x y direction. That is, you can write sx equal to v naught x t plus half ax into t square, and sy, where s represent displacement, sy equal to v naught y into t plus half y into t square. Thus, motion in a plane can be treated as two separate simultaneous one-dimensional motion with constant acceleration along two perpendicular directions. Now, relative velocity in two dimensions, because we have velocity VAB, that is velocity of object A with respect to object B, equals to VA vector minus VB vector, where VA and VB are the velocity with respect to ground. Now this can be written in component form like VABX into I cap plus VAB into Y into J caps and equals to VAX into I cap plus VAY into J cap minus VBX into I cap plus VBY into J cap. Now this can be written as VABY equals to uh, VAY minus VBY. Rain is falling vertically with a speed of 35 meter per second. A woman rides a bicycle with a speed of 12 meter per second east to west direction. What is the direction in which the she should hold the umbrella? The situation is shown in the figure. This represents the velocity of rain and this is the velocity of bicycle. So and this represent the velocity of this velocity, this line represent the, this vector represent the velocity of rain with respect to bicycle, that is Vr minus Vb, and the corresponding direction is shown east, west, north and south. So Vrv equal to velocity of rain with respect to bicycle, Vr minus Vb equal to Vr plus minus of Vb vector. Now tan theta equals to mode of minus Vb by mode of Vr equals to 12 by 35 equal to 0.343. Hence theta equals to tan inverse 0.343 equals to 90 degree. So theta here will be 90 degree. चलो ये